Measures of data variation. Variation is a measure of dispersion or spread in the data. And sometimes we can even say it's a measure of distribution or spread in the data. Let's remember that when we're talking about statistics, we're often talking about multiple instances, multiple observations, and of one or more specific variable. So we can see to what extent all the different values of one variable even are distinct from themselves from across the instances. As the extent to which values are close together or far apart is another way to think about it. So for example, the range of price fluctuation for a stock. So does the stock that you're thinking about go from 80 to 82 in one day and then back to 81 and then to $83? Or does it go from $50 to $100 in one day and to $1,000 and then to $2? So does it have a variation like Bitcoin, or does it have a variation like a more standard stock? Variation in student grades, variation in scores per game, any kind of quantitative variable for multiple instances is going to have some variation, unless it's always the same, and usually that's not the case. So measures of variation can refer to specific data values or aggregate measure, a measure of aggregation. So for example, the maximum value is a specific data value. The minimum value that you find is a specific data value, but the mean is an aggregate measure. It's the sum of all the values divided by the number of instances. It's an aggregation. So I have some examples here of variation. This is a kind of dot plot, not like the dot plot shown in the textbook, but a kind of dot plot, and each dot has to do with the items for sale. So each plot is a item for sale, some produce like beans and corn and things like that. So here we see lower variation because all the values kind of stay within close to kind of a trend. But here we see greater variation. One item costs $3, another item costs $11, another costs $12, another costs $1. Here, most items cost between 3 and 5, or almost all items cost between 3 and 5. So low variation, higher variation. If we think about what's the maximum and minimum value here in this graph, maximum value looks to be 12, and minimum value looks to be 180 or something like that here. So these are the specific values, and that's what I mean by this statement here. Now, if we get the mean, what's the average of all of these values here, then it's going to be something like maybe over here, like 8.2, right? So it's an aggregate measure. It's not a measure of any one specific value. It's just an aggregation of all the values. So there are 4 measures of variation that we're going to be discussing: range, variance, standard deviation, and inter-quartile range. Range is the most straightforward one. It's the difference or distance between the maximum and minimum values of a data distribution. That is, when I say data distribution, I just mean, the set of values of the data set that you have of the multiple instances. And we can think about it as that difference itself, or we can also think about it as the minimum and the maximum value. So it's usually important to know the minimum and the maximum value and not just the difference. So sometimes you give a range. So for example, here we have the goods that we were talking about before, beans and rice and corn. We have 2 quantitative variables, amount sold and price per pound. If we see the range of amount sold is the minimum minus the maximum value. So amount sold, this is a quantity. So here 15 is the minimum and 85 is the maximum. So the range is 70, but it's always good to report the minimum and the maximum. That's how it's usually reported. And then we can just derive the range, because when you just say 70, it could be from 1 to 71 or from 1 million to 1,070,000. So it's, when we talk about range, always focus on reporting minimum value and maximum value, and then the other person can just find out the difference. There is a way to also see kind of indirectly the range via bar graph visualization. So if you visualize the bar graph in an order way, you can see that the range, you can kind of see the range from the minimum to the maximum here. So you can kind of infer or visualize indirectly the range by some kind of bar graph or other kind of graph visualization. Variance. Variance is a measure of the dispersion of the data about the mean, surrounding the mean. And it's a squared average of difference between all the values and the mean. So we talked about the mean before. The mean is the sum of all the values of a variable divided by the number of instances. So let's focus on amounts sold here. The variance is going to be the sum. So this is the sum. This is the variance here. It's a squared number like this, but you see why later. The variance is the sum of the difference of all the values. So this is here the value of the data minus the mean. So data value, let's say. The X bar is the mean of the sample. And it's squared. And it's squared because sometimes the data value is going to be minus the mean is going to be negative. And then if you sum and then subtract all the differences between the values and the mean, you would actually get a 0. And so you always get 0. So you need to square to make all the values positive. So we actually see the difference, just the difference between all the values and the mean. So what do I mean by all the values? Well, here we have one item, the value is 15. So 15, let's kind of actually go through this process. 15 minus average is 30.5. I already got the average before. The average, you got the average of all these items here. It amounts to 30.5. So 15 minus 30.5 equals, see, we already got a negative number here. It's 15.5. And then what we do, we square that. We square that. And for the order of operations, we don't divide yet. So then because we want to sum all of this first. So, and then we do 15. What's the next value? Well, 15, and then we see the same thing. And then the next value, 20. So we do 20. We don't skip the second 15. I'm just skipping because it's the same as the previous one. And then 20 minus 30.5 equals 5.5, and square that. And then you sum that. This is actually negative 15 and negative 5. You square that, and then you square that, and this means sum all of these as you go along, and then divide it by the total number of instances minus 1, and then you get the variance. And in this case here, the variance is gonna be, you can calculate it in Excel, and you can calculate it in R, and it's gonna be 413. Variance is always positive, and greater values will indicate higher dispersion. So the higher the variance, the higher the dispersion. The problem with the variance is that because we squared the items in here to get rid of the negatives, we usually have this very high number that doesn't kind of match the other numbers that we see with the variable that we're talking about. So generally the amount sold is 15, 15, 20, and we can think of this as pounds. So amount sold means pounds. 15 pounds, 20 pounds, 25 pounds, and so on. So what's 413? Just sounds out of scope. Well, this is okay, so this is another way to view the data. So the average here, this kind of dot plot I kind of made up. It's more like a bar graph, but without the bar and a dot instead. Notice that there's no quantitative variable here. These are the categories. So this is beans. This is another kind of, black beans and garbanzo beans and white rice, each dot. So this is categorical. We already calculated those numbers, and you can kind of see here, it's nice to always graph, right? Because you can visualize, whoa, this value here is way up there. It looks like an outlier. So to address that problem, we usually don't use that variance directly. We use the standard deviation, which is just the square root of the variance. And this is kind of why we put the variance as this squared number, because usually we want to take the square root of the values and make a more what I call a kind of average variance. I don't think this is technically correct, but it helps me think about it. Just the general variance, or just the standardized measure of the variance of the distribution of the data about the mean, which is the variance. And essentially, it's that value we had square root. So we had the value here already, 413. So if you take the square root of that, we get 23.33, which is a much more within the scope of the actually amounts that we see on the amounts sold, right? So the standard deviation is the standardized measure of how much the values of the particular variable disperse. And the standard deviation is 23, so this disperse about 23 pounds around the mean, which is 30. So mean equals 30, and then the standard deviation is 23. Let's say, just round it up, 23, and then 23 here. So we can say that most values of the data are between 30, 20, and 20 minus 23 is 7, and 30 and plus 23 is 53. So as we see later, we see, okay, we can say most of the data is within one standard deviation of the mean. So the values here would be between 7 and 53. And it kind of goes much below it than any values we see here. But that's because this distribution is kind of skewed. So I hope that makes some sense about the measure of this dispersion. And we usually are going to use standard deviation, and rarely we're going to use a variance. So the average is 30, the standard deviation is 23, and this is more interpretive. We can think about it as 23 pounds. The average amount sold is 30 pounds. Standard deviation is 23 pounds around the mean. Let's remember that it's about the mean, or around the mean. Here's just another calculation focused on the price per pound. And we can think about it. We always think about it as per specific variables, right? So you can kind of do the analysis too, or if this is a large variation or a small variation. The other one seemed kind of high, as we saw here. There's a lot of variation in this price with this standard deviation measure, but perhaps less so for the prices. Think about it. And lastly, there is the inter-quartile range. So the inter-quartile range is talking about the percentile. So this is when we put the data in some kind of order. The previous measures, except for range, we did not need to put the data in any kind of order. Well, when we're talking about quartiles, we're talking about the ordered data. Let's remember. So the inter-quartile range is the middle 50% of the data instances, and the values corresponding to those, or between the 25 percentile to 75 percentile, or top of the Q1 and top of the Q3. So let's remember the box and whisker plot. So usually this here means the max value and the min value. Max value, and then here would mean the min value, but then sometimes it changes because they put the outliers there. So technically, this is the min value. You could also graph it this way. Min values here. This is the top of Q1. So this is the first quartile here between the minimum value and then this line here. this line, which is about, let's say 82 or 84, right? If I remember from last time. This here is the median. So the first quartile, the second quartile, this is the top of this is the 50th percentile or median. And then here is the Q3 or 75 percentile, which in this case is, well, let's say the median is about what? Maybe 92, and then Q3 is about 96, let's say. So in this case, the interquartile range is going to be what? Think about it. Well, it's going to be 84 to 96. That's the I interquartile range. And sometimes they'll just give you the difference so of these two. So in this case would be, did I do that right? Yes, that does look right. So that would be 6 plus 6, so 12. Once again, every time we're talking about range, it's good to give the minimum value and the maximum and not just the difference. But that's what the interquartile range is when we're usually talking about it. Okay. And just to have some kind of exemplification of these measures, let's look at these two data sets here. One of the goods sold in market 1, and then the similar set of goods sold in market 2. So this is a farmer who sells in 2 different markets, and he's collecting data of all the amounts sold and then the price per pounds of all the different items. And you can generate descriptive statistics, also called exploratory statistics, for these 2 markets to understand their measures of central tendencies, their typical values of the variables at interest, as well as the dispersion. So in the market 1, for amounts sold, so these are the pounds of items sold, there was a 30 pounds of amounts sold on average, mean average, but the median was 27. In the market 2, there were 31 pounds of amounts of products sold, but the median was 25. So while it may seem that market 2 in general, in the aggregate, sold more pounds, slightly more pounds if you use a mean, but if you use a median, it looks like it sold less. So this is why it's important to think about these measures. The variance, let's focus on standard deviation. So standard deviation on the market 1 is 20, and standard deviation on market 2 is 16. So it seems there is more wild dispersion, wild variation in market 1 compared to market 2 regarding how the different items were sold. And the same for the interquartile range. So in the market 1, interquartile range is 10 or between 20 and 30 amounts of pounds sold. And the market 2 is 5. So it's very much less in market 2, the variation in market 2 compared to market 1. And that's it for some of these measures of variation, and we'll continue next time.